Hi guys, welcome back to Technowizard. So yeah, let's get started with the video. So you can also follow us on the Facebook, Instagram or the Telegram channel for more updates. So yeah, let's get started with the first question. So two networks are said to be dual when their node equations are the same. The loop equation of one network are analogous to the node equation of the other. Their loop equations are the same. The voltage source of one network are the current source of the other. Okay, so for this question option B is correct because the two physical systems are called dual if they are described by the equation of same mathematical form. Okay, so for this question option B is correct. So when the loop equation of one network is analogous, means similar to the node equation of the other, then the two networks are said to be dual. Okay, so next question is the dual of a parallel RC circuit is. Okay, so in order to find the duality of a C parallel RC circuit, so the parallel dual will be series. Okay, and for RC it will be RL. Okay, so the dual of a parallel RC circuit is a series RL circuit. So other principles of duality holds good for the resistance duality is conductance. Okay, and the inductance duality is capacitance. Short circuit duality is open circuit. Okay, and also voltage source duality is current source. And other forms are like series branch will be represented by shunt branch. Okay, so for this question option B is correct. Next question is, in an electric circuit the number of independent meshes M is, where B is the number of branches and the N is the number of nodes. So basically we have to calculate the number of mesh equations, which is given by B minus n plus 1. Okay, so option B is correct, where B is the number of branches and n is the number of nodes. Okay, so next question is, the number of branches in a network is B, the number of nodes is n, and the number of dependent loop is L. The number of independent current equation will be. So we know that we will obtain the current equation using the nodal analysis, and the number of equations to be solved using the nodal analysis is given by n minus 1. Okay, so the number of equations to be solved by nodal is given by n minus 1 minus 1 to exclude the reference node, because we don't apply the nodal at the reference node. Okay, so that's why minus 1. So option D is correct. Next question we have is, the number of independent KVL and the KCL equations for a network with n nodes and L links are respectively. So basically if there are L links present in a network and n nodes, so the KVL equation is given by L, and the KCL already stated in the previous question, it will be given by n minus 1. So for this question option B is correct. I will explain later on what are links and other those things, okay, in the upcoming questions. See, so this is our next question. The graph associated with an electrical network has 7 branches and the 5 nodes. The number of independent KCL equations and the number of independent KVL equations respectively are. So first of all we have to find out the number of independent KCL equation, which is given by n minus 1. So they have already given the number of nodes they have is 5, so this will be 5 minus 1, so this is 4. And the number of KVL equation is given by B minus n plus 1. So the number of branches are 7 minus 5 plus 1, which is equal to 3. So option D is correct. Okay, so next question is, the network has 10 nodes and the 17 branches, the number of different node pair voltage would be. Okay, so for this question we have to calculate the node pair voltage, which is given by NC2, which is equal to n into n minus 1 by 2, where n is the number of nodes, which is given by 10 into 10 minus 1 by 2, which is equal to 10 into 9 by 2, which is equal to 45. So option D is correct. Okay, so next question is, in a network with the 12 circuit elements and the 5 nodes, what is the minimum number of mesh equation? So we know that the mesh equation minimum number of mesh equation is given by b minus n plus 1. So they have not given number of branches directly, so here they have given us 12 circuit element. We know that every element is considered as a branch. Okay, so this implies that the number of branches they have given us 12 and the number of nodes are 5. So let's substitute the values. So this is 12 minus 5 plus 1, which is equal to 7 plus 1, which is equal to 8. So option D is correct. Next question is, what is the number of chords of a connected graph G of the n vertices and e edges? So vertices are nothing but node. They can, other name for the node is vertices, and edges are nothing but our branches. Okay, so now in the question it is asking that we have to calculate the number of chord. So another name for the chord is link, or the formula resembles with the number of mesh equations. Okay, so which is given by b minus n plus 1. So in place of branches they have given us edges denoted by e, and they have n vertices, so this is n plus 1. So number of chords is given by the relation e minus n plus 1. So option D is correct. Okay, so now next question is, the number of edges in a complete graph of n vertices is. So basically if we have to calculate the total number of branches present in a graph, which is given by n into n minus 1 by 2. Okay, so option D is correct. Next question is, consider the network graph shown in the figure. Which one of the following is not a tree of the graph? So basically this is called a graph. Graph is obtained from the electrical network. Okay, so basically any electrical network can be represented by its graph. So now we have to calculate the tree. Okay, so tree is basically a sub-connected part of graph. So tree branches are denoted by the dark line. Okay, so dark and solid lines like this. So these are the branches of the tree. So now we have to find out in this question which is not a tree. So first of all, let's find the number of branches in a tree. So number of the branches in a tree is also called as twig. Okay, another name for the tree branch, in short we called it as a tree, which is given by n minus 1, where n is a number of nodes in the graph. So in this graph the number of nodes are 1 2 3 and 4. So this will be 4 minus 1, which is equal to 3. Okay, so we must consider the 3 branches from this graph in order to obtain a tree. Next condition for the tree is they should not form a closed path. Okay, so no closed loop or path should be formed. Should be formed. Okay, so now see here, for the in the option A we are considering the three branches. Okay, so this is first, this is second, and this is third branch, so this is right. But in the option B, here is a closed loop forming, so this option is wrong. Okay, it means this is not a tree, and in the question it is asking which is not a tree, so this option is correct. So this is also correct because this is a tree. Here this is branch 1, 2 and 3, so I'm considering three branches and no closed loop is formed. This is also right, so option B is correct. Similarly, next question is, consider the following graph. This is the graph they have given, so they have also mentioned the branches. Okay, which one of the following is not a tree of the above graph? So in this graph the total number of nodes present is 1, 2, 3 and 4. Okay, now the tree branch is given by n minus 1, which is equal to 4 minus 1 is equal to 3. So basically we have to consider any three branch and they should not form any closed loop. Okay, so this is right option. Okay, because it is not forming any closed path. This is also right, so this is first branch, this is second, and this is third branch. Option D is also right because this is first, second and third branch and they are not forming any closed path. But option C is wrong, this is not a tree because here only the two branches are considered, but we have to consider the three branches, so not a tree. So option C is not a tree. Okay, so next question is, okay, one more thing I would like to explain here is, the other branches remaining are called as a chord or a link. Okay, so now we have in the option A we have considered the branch 1, branch 2 and branch 3. The remaining branches, which are 4, 5 and 6, are called as link or the chord for this tree. Okay, similarly, if we are considering this tree, then our link and chord will change accordingly. So in this tree it will be 1, 4 and 5 will be links and chord. Okay, so that's why the tree and or the link or graph are not unique, it will vary according to the question. Okay, so now next question is, in the graph shown in the figure, one possible tree is formed by the branches 4, 5, 6, 7. Okay, so basically it is saying that they have given us a graph and now they are considering a possible tree which is formed by the branches 4, 5, 6 and 7. Then one possible fundamental loop is, okay, so first of all let's draw a tree. So we always represent a tree by a solid dark line and the links are represented by the dotted lines. Okay, so now they are considering the branch 4, 5, 6, 7 as a tree, so I'm gonna represent them by the dark or the solid lines. So this is branch 6, 7, 4 and 5. Okay, so this is branch 5, this is 4, this is 6 and this is 7. Okay, so this is the nodes. Now the remaining branches, they will be represented by the dotted lines and they are called as link and chord. Okay, so this is branch 1, this is branch 2, this is link 3 and this is link or chord 8. Okay, so now it is saying that then one possible fundamental loop is, so fundamental loop is that loop which contain a single link within it. Okay, so fundamental loop is that loop which contain only one link in that loop. So now we have to find out that loop. So now in the option, it is first option is 1, 4 and 5. So 1, 4 and 5 is not forming any loop. Okay, so loop is always closed path, so this is not a closed path in the option A. Okay, so 1, 4 and 5 is not forming any closed path, so this option is wrong. Next option is 2, 3 and 5. So 2, 3 and 5 is forming a closed path, but here the two links are included, so this is not a fundamental loop. Okay, because here the two links, link 2 and link 3, are involved, but the definition for the fundamental loop is that it should contain only a single link. Okay, so now next option is 3, 4 and 8. So 3, 4 and 8 is also not forming a closed path, so this is also wrong. Next option is 6, 7 and 8. So 6, 7 and 8 is forming a closed path. Also there is a single link present in this loop, so this option is correct. Okay, so for this question D option is correct. Next question is the number of chords in the graph of the given circuit. So basically they have given us a graph. Now we have to calculate the number of chord. Another name for the chord is given by link, already explained. So the formula for the number of chord or link is given by b minus n plus 1. So now in this graph the number of branches, so this voltage source will be considered as a single branch, this inductor is another branch, this resistor is third branch, this is fourth branch, this is fifth branch, and this is sixth branch. Okay, so now number of branches present here is 6. Here the number of nodes, this is first, second, third and fourth, and my plus 1, so this is 3. So option A is correct. Next question is what is the total number of trees for the graph shown in the figure. So basically if we have to calculate the total number of possible trees in a graph, so total number of possible tree in a graph, so this is given by the relation n to the power n minus 2, where n is the number of nodes. So this is node 1, this is node 2, this is node 3, and this is node 4. So in this graph 4 nodes are present, so this will be 4 to the power 4 minus 2, which is equal to 4 to the power 2, so which is equal to 16. So for this graph 16 trees can be possible. Okay, so option D is correct. Next question is consider the following statements with regard to a complete incidence matrix. Okay, the sum of the entries in any column is 0. The rank of the matrix is n minus 1, where n is the number of nodes. The determinant of the matrix of a closed loop is 0. So basically incidence matrix is obtained from graph. Okay, so we can represent our graph with the help of matrix. Okay, so now it is saying that the sum of the entries in any column is 0, so this is right statement. Okay, the rank of the matrix, this is important, so the rank of the matrix is n minus 1, so this statement is also right, and the determinant of the matrix of a closed loop is 0, so this is also right. So which of the above statement are correct? So option D is correct. So now here I will explain what is an incidence matrix. So now the incidence matrix A of a connected graph is given below. So basically they have, for a connected graph they have given us a incidence matrix. So this is incidence matrix. So here they are representing the number of nodes and here the branches. It means the graph has 4 nodes and 6 branches. Now the following statements are associated with the above matrix. So let us first draw the graph from the matrices they have given. Okay, so now first draw the graph. So now I will mark the 4 nodes they have mentioned. So suppose this is node 1, this is node 2, this is node 3, and this is node 4. Okay, so I have marked nodes. So suppose this is node 1, node 2, node 3, and this is node 4. Now here the branch 1, so this is branch 1, it is connected between the node 1 and node 4. Okay, so branch 1 is connected between the node 1 and 4. Okay, so I'm gonna draw a branch like this. So this is connected between the node 1 and 2, so this is plus 1. This indicates, it means this branch is going in the outward direction from the node 1 towards the node 4, because at the node 4 the direction is in the it is inward to the node 4, so that's why it will be minus 1 at the node 4, and it is going out from the node 1, so it will be plus 1. Okay, Similarly, the branch 2 is connected between the node 3 and 4. So let's draw it like this. So this is our, okay, so this is branch 1. Okay, now this is branch 2. It is connected between the node 3 and 4. So this is node 3 and this is 4. Okay, so positive is toward the node 3, so this means the current is flowing in this direction. Now branch 3 is connected between the 3 and 4, so this will be like this, and positive toward the 3. Okay, so this is like this, and this is branch 3. Okay, so now next branch 4 is connected between the node 1 and 2, so it will be like this. So positive towards 2, it means it will be going out. So this is our branch 4. Now branch 5 is connected between the node 2 and node 3, so this is this, and positive, so it will be going out from the node 3. Okay, so this is our node, sorry, branch 5. And next is branch 6 is connected between the node 1 and 3, so this will be like this, and positive towards the branch, so this is positive, it means outward from the node 3. Okay, so this is branch 6. Now see the statements. The following statements are associated with the above matrix. Branch 2 and 3 are in series. So this is branch 2 and this is branch 3. So they are connected in parallel. So this statement is wrong. Branch 4 and 5 are in series. So this statement is right. Now the voltages of the branch 4, 5 and 6 forms an independent set. So this statement is wrong because the voltages of the branch 4, 5, 6 will also depend on the other branch also. So this statement is wrong. So option B is correct. Okay, so now in the previous question we have seen that the first statement is the sum of the entries in any column is 0. So see here, these are our column, so you can add any column, you will get the 0. Okay, so this is 0, it means this is a complete incidence matrix. Okay, so that was the previous question. So yeah, thank you guys for watching this video.